Good day, learners. Welcome to mathematics lesson. My name is Nonkululeko Mboyisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. In today's lesson, we'll be looking at statistics, which is the topic that talks about, or where we are looking at the practice or science of collecting and analyzing data. At the end of this lesson, you should be able to determine the measures of central tendency, whereby when we are looking at the measures of central tendency, we are looking at the mean, we are looking at the median, and we are looking at the mode. So you should be able to determine the measures of central tendency, which is the mean, median, and the mode, in grouped and ungrouped data. So when we are looking at the grouped data, we are looking at that data that has been put in intervals. And when we are looking at the ungrouped data, we are talking about that data that hasn't been put in intervals. Number two, you should be able to determine measures of dispersion in grouped and ungrouped data. When we are looking at the measures of dispersion, we are looking at your range, we are looking at your quartiles, we are looking at your interquartile range, and we are also looking at your percentiles. Number three, you should be able to determine your 5-number summary. Remember, when we are looking at the 5-number summary, we are looking at your mean, we are looking at your lower quartile, your median, your upper quartile, and your maximum value. And then number four, you should be able to use that 5-number summary to sketch the box and the whisker diagram. Remember, this is all revision because you have done this in the previous year in grade 10. Okay, so under the measures of central tendency of the ungrouped data, we will be looking at the mean, whereby when we are talking about the mean, we are talking about the average. And then we'll be looking at the median, of which it's the meekly value of the data set, and then the mode, which is the most frequent value in the data set, or the data that appears the most, or we say the value that appears the most in your data set. Okay, firstly, let's start by looking at the mean. How do you obtain a mean? You obtain the mean by adding up all the scores, then divide by the total number of scores. Mean can be distorted if you have a small class and 1 or 2 learners do badly on the test. The average will be lower than if you have a large class. This also works the other if 1 or more learners do very well. The average will tend to be too high as compared to the larger class. Okay, so the formula for finding the mean, remember the mean we denote it as the X bar. The X bar, whenever you see the X bar, you must know that they are talking about the mean, right? So the mean, you find it by adding the total of that data set that you are given and then dividing by the number of terms. Let's look at example number 1. Example number 1, you are given 67, 78, 21, 42, 80, 71, 33, and 91. They say determine the mean of the following set of data. So with this data set, we say it's ungrouped because it has not been put in intervals, right? So how do you find your mean? You'll say your mean is given as the X bar. It is equals to 67 plus 78 plus 21 plus 42 plus 80 plus 71 plus 33 plus 99. So you add each and every value and then you divide by the total number, which is how many? You have 1, 2, 3, 4, 5, 6, 7, 8. So it means you are going to divide by 8. So your mean will be given as, please take out your calculators. Okay, and then you'll press 67 plus 78 plus 21 plus 42 plus 80 plus 71 plus 33 plus 99. Then you divide everything by 8 and you will get 491 all over 8. So your x bar will be given as 61,38. So your mean will be given as 61,38. Okay, now let's look at the mode. The mode, I had said previously, it's the most commonly occurring observation, or you can say it's the value that appears the most. Okay, so example number 2, they're now saying write down the mode. So you are checking your values. You can see you've got 22. Do you have another 22? Okay, yes, you have another 22. And then do you have another 22? Yes, you have another 22. So you've got 3 22s. And then you go to 32. Do you have any other 32? No. You go to 31. Do you have any other 31s? No. And then you go to 20. Do you have any other 20s? No, you don't. So it means your mode, it is given as 22. Done. Okay. And then the median. So the median is the middlemost score for an odd number of the scores. So if you've got if you are finding your median and you have only one value, let's say for instance you've got 5 values. I'll just make an example. Maybe you've got 1, you've got 3, you've got 4, you've got 6, you've got 7. So when you are talking about the median, we are talking about this middle value. If your numbers, they are odd, because now I've got 5 numbers, it means these are odd numbers. Okay, so it's going to be the middle value, which in that case is going to be 4. So your median in that data set, it is given as 4. But then, what if you are given a data set that is even? Maybe let's say you've got 1 is to 3 is to 4 is to 6 is to 7 is to 8. So now if I'm looking at the values in between, or the middle values, it is not only one value, but it's an even number. It's going to be 2 values. So the middle from 1, it's going to be 1, 2, up until 4, and then from 8 to 7 you have that 6, right? So it means the middle value there, it is going to be 4 and the 6. So how do you find the median when you've got 2 values that are in the middle? So you are going to say it's 4 plus 6, then you divide by 2, right? Then 4 plus 6, it is going to give you 10, and then when you divide by 2, it is going to be 5. So it means your median, it is given as the 5. So scores should first be arranged in an increasing order before the median can be calculated. So before you can find the median, it is very important that you arrange your data set in an increasing order, or you arrange your data set in an ascending order. Ne? So you must always arrange your data set from the smallest to the biggest. Okay, so the median is not affected by extremely high or low values and is therefore a good measure of central tendency. Unlike the mean, which is affected by extremely high or low values, median is not affected by high or low values and is therefore a good measure of central tendency. Okay, let's move to the formula of finding the position of the median. So remember, the median, we are talking about the middle of your data set, right? So it means we are talking about the 50% of the data set. So how can you find a number of 50%? 50%, if you divide it by 100, you'll get 1 all over 2. So it means you can say 1 all over 2 times n plus the 1 to find the position of the median. Remember, this formula, it doesn't give you the median. It only gives you the position of the median. And n is the number of elements in the data set. Okay, so let's look at example number 3. Example number 3, it says determine the median of the data set. So I am given 1 is to 5, is to 6, is to 2, is to 10, is to 9, is to 16. So if you look nicely at your data set, you'll realize that your data set is not arranged in an increasing order or in an ascending order. So you need to make sure that you first arrange your data set. Ne? So the first value there is going to be 1. I'm done with 1, and then I'll go to 2. I'm done with 2, and then I'll go to 5. I'm done with 5, then I move to 6. I'm done with 6, then I move to 9. I'm done with 9, then I move to 10. I'm done with 10, and then I move to 16. So now I have arranged my data set in an ascending order. Ne? So after doing that, I can now find the position of my median. Remember, your median is just the middle value. So you can also just look at your data set and just find your median without using the formula of the position. But I prefer to use the formula of the position because it doesn't matter how many values you have. Even if you've got a large data set, you can still use the position. Ne? So you can say this one is in position 1, this one is in the last position, second last in the second, and then you have the third position, and then you've got the third last. So it means your median is given by 6 just by looking at your data set. But what if you are going to use the formula of finding the position? So you must say it's the position. It is equals to 1 all over 2. Remember, I said when we are talking about the median, we are talking about half of the data, right? So you say 1 over 2 into n plus 1. So you say 1, sorry. So let me just write on the side. You say it is equals to 1 all over 2 into, where there is n, remember we said n, it stands for the number of the data set. Ne? So how many values do I have here? I have 1, 2, 3, 4, 5, 6, 7. So you'll substitute the 7, you say it's plus 1. Then everything, it's going to give me 8 all over 2, which is going to be 4. This 4 is not the median, but it is the position of the median. It means if I go to my data set in position 4, I'll find my median, right? Okay, so I go to my data set, I've got position 1, I am getting 1. In position 2, I am getting 2. In position 5, I am getting, sorry, in position 3, I am getting 5. And then in position 4, I am getting the 6. So it means your median, it is given as 6, right? Because it's in position number 4. I hope you got that one. Let's move to example number 5. Let's say now you are given an example whereby your data set is an even number. Ne? Okay, so first things first, I can see my data set is not arranged in an ascending order, right? So first things first, we need to arrange our data set in an ascending order. Okay, so the smallest value here, it is 1. So it means I'll start by putting 1. And then the second value is going to be 3. Do I have a 4? Yes, I have a 4. Do I have a 5? Yes, I have a 5. Do I have a 6? Yes, I have a 6. Do I have a 7? Yes, I have a 7. Do I have an 8? Yes, I have an 8. And then I have a 9. Okay, so I have arranged my data in an ascending order. Ne? I have arranged my data in an ascending order. So I can just look at my data and find the median, or I can use the position to find the median. So it's up to you. Okay, let's say position, it is given as 1 all over 2 into n plus 1. So it's 1 all over 2. The number of the data set, you've got how many values here? It's 1, 2, 3, 4, 5, 6, 7, 8. Ne? So it means you have 8 plus 1, which is going to give you 9 all over 2. And 9 all over 2, it's going to give you 4, 5. So it means you will find your median in position 4, 5. Ne? Okay. So I have position 1, I have position 2, I have position 3, I have position 4. Ne? So they say we said our median, our position of the median is in position 4,5. So I have position 4. So in 4,5, it means 4,5 is between 5 and 6, right? Even if you check, if you are starting to calculate from the other side, it's going to be 1, 2, 3, 4. 4,5 is in between 5 and the 6. So it means my median, I'll find my median in between 5 and 6. So in this case, what do you do if you've got two values that are your median? You are going to say your median, it is given as 5 plus 6 all over 2. So 5 plus 6, it is going to give you an 11, and then you divide it by 2, it is going to give you 5,5. So it means your median, it is given as 5,5. Okay, let's look at activity number 1. So number 1, you are given class results for a test out of 30 are recorded in the table below. So you've got 10A, you've got 10B, you've got 10C, and then they gave you the test results. Ne? So letter A, it says calculate the mean for each class. So you need to calculate the mean for each class. And then letter B, it says you need to calculate the mode for each class. And then letter C, it says you need to calculate the median for each class. Ne? Letter A, calculate the mean for each class, right? So as I had said, the mean, you'll say X bar, it is equals to. So you add each and every value. So you'll say 15 plus 22 plus the 16 plus the 17 plus the 15 plus the 16 plus the 12 plus 16 plus 11. So if I add everything, I am getting 140. You will correct me if my answer is incorrect. Ne? So you divide by the total number of the data set, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you divide by 9. So if I say 140 divided by 9, I am getting 15,56. Please just double check. Okay, and then now I am going to calculate the mean for 10B. So again, you'll say the 8 plus 13 plus the 14. 8 plus 13 plus 14 plus 30 plus 27 plus 23 plus 24 plus 20 plus 19. So I am getting 178. So it's 178, and then you divide the 178 by the total number. So obviously it is going to be the same total number as 10A. So I divide by 9, ne? And then you will get 19,78. Give yourself just 2 ticks like that and 2 ticks like that. Okay, again, X bar for 10C. I am going to add everything. So you'll say 14 plus 626 plus 14 plus 14 plus 12 plus 14. Just add everything. Plus 12 plus 21 plus the 5. I am getting 132. 132, you divide it by 9. If you divide it by 9, you will get 14,67. Again, you give yourself just 2 ticks for the total and the answer. Ne? I hope you all got this one correctly. Let's move to the second one. Oh no, I made a mistake. This is for the mean, okay? So the mean, which is letter A, we got 140 divided by 9, eh? And then which was 15,57. and then it was 2 ticks. And then the second one, we got 178 divided by 9. And then we got 19,78. Again, I said 2 ticks, ne? And then the last one, which is 10C, it was 132 divided by 9 as well, and we got 14,67, right? Forgive me for that mistake. Okay, so that was letter A, whereby you are supposed to calculate the mean. So let's move to letter B, whereby now you need to find the mode. Mode, you just look at your data set and find the mode. You don't have to calculate. So the mode for 10A, let's look at class 10A. So the mode for 10A, you go back to your class year 10A, and then you check. I've got 15. Do I have another 15? Yes, I have another 15 here. And then I have 22. Do I have another 22? No. 16. Do I have another 16? Yes, I've got 16, and I've got another 16. Oh, and I have another 16. So I've got 3 16s, and I've got 2 15s. 17s, it's only 1. 12, it's only 1. 11, it's only 1. So it means the number that appears the most in that case, it is going to be 16. Why are we not taking 15? Because 15 only appears twice, and 16, it appears 3 times. Ne? So our mode for that data set, it is going to be 16. And then we move to, you're just going to get 1 mark for that. We move to 10B. Class 10B, let's check. I've got 8. Do I have another 8? No. I have 13. Do I have another 13? No, I don't have another 13. I have 14. Do I have another 14? No. I have 30. Do I have another 30? No. 27. Do I have another one? No. I've got 23. Do I have another one? No. 24, 20, and 19. So it means for the class of 10B, I don't have a mode, ne? So you just say no mode. Please don't create your own mode. You only write a mode if it exists. If it doesn't exist, then it means you don't have it, ne? And then let's move to 10C. 10C, I've got 14, and I have another 14, and then I have another 14, and I have another 14. So the 14, it appears how many times? 4 times. I move to 26. Do I have another 26? No. And then I have 12. Do I have another 12? Yes, I've got 12, and I have another 12. And then I have 21. Do I have another 21? No. I have a 5. Do I have another 5? No, I don't have another 5. So it means the number that appears the most in that case in 10C, it is going to be 14, because 14 appears 4 times. Ne? So you say your mode, it's 14. Why are we not choosing 12? Because the 12, it only appears 2 times. Ne? Okay, I hope you understand the mode now. Ne? So the mode, we said it's the number that appears the most. Okay, let's move to a median. Remember, with the mode, guys, you can't just find the mode without arranging your data set. Arranging your data set is very important. So the question, it says calculate the median for each class. Ne? So we'll start by calculating the median for 10A, class 10A. So I've got 10A. First things first, we need to arrange our data in an ascending order. Don't forget, in an increasing order. Ne? So class 10A, I have, which one is the smallest one here? I've got 15, 22, 16, 17, 15, 11 is the smallest one. So I start with 11. And then do I have a 12? Yes, I have a 12. Do I have a 13? No. 14? No. 15? Yes. And I have another 15 here. Do I have another 15? No. And then I have 16. Do I have another 16? Yes. Do I have another 16? Yes. And then I have a 17. And then I have a 22. I think 22 is the last term, ne? Okay. So now we can find the position. Our data has been arranged in an ascending order. Good. But there's no mark for arranging your data in an ascending order. Okay, let's find the position. Your position, we said it's 1 all over 2 into n plus 1, right? So it is going to be 1 over 2 into how many data do you have? Data set, we said it's 9, right? So it's 9 plus 1. So you will get 10 all over 2, which is 5. Ne? Remember, this is just a position. It's just a position. 5 is not your median, but it's the position of the median. So let's go to the arranged data set to find the position of that median. So I have 1, 2, 3, 4, and 5. So we said it's in position 5, right? So it's in this position. Let me check if this half, the upper half, is also 4 numbers. It's 1, 2, 3, 4. It's also 1, 2, 3, 4. So it means our median, it is given as 16. Then you get your full marks. Okay. Let's move to class B. Class B, first things first, we need to arrange our data set in an ascending order. Okay, so I can see there's 8. Okay, 8 is the smallest one. Do I have a 9? No. A 10? No. 11? No. 12? No. 13? Yes. And then I have a 14. Yes. And then 15? No, I don't have a 15. I can see 19. And then there's a 20. And then there's 23. And then there's 24. And then there's 27. And then there's 30. Okay. So let's find the position of that data set. Position, you say position. It is going to be 1 all over 2. It's equals to 1 over 2 into n plus 1. So it is going to be 1 over 2 into the total number of the data set. It's 9 plus 1. So it is going to be in position 5 as well. Ne? So you go to position 5. So it's position 1, 2, position 3, position 4, position 5. So in position 5, I will have 20. So it means my median, it is given as 20, right? And then you get your full marks. Okay, and then let's quickly do the last one, which is 10C. So if I arrange my data set in an ascending order, I will start with 5. And then I'll have 6. I don't have a 6, 7, 8, 9, 10, 11, 12, 13. Oh, I do have a 12. I have another 12. Do we have a 13? No, we have a 14, 2, 3, 4. So we've got 4 14s. 1, 2, 3, 4. Ne? Okay, and then we have 21. And then we have 26. So the position, guys, is going to be a repetition because the number of the data set is the same. Ne? So it means even this one is going to be in position 5. So you go to position 5 there, you'll say it's position 1, position 2, 3, 4, 5. So it means your median, it is going to be 14. I don't know if there's anyone with a question. I hope you all understand how to find the median. Ne? Let's move. Okay, now let's look at the measure of central tendency in a grouped data. So we're looking at the measures of central tendency in an ungrouped data. Ne? So now we are looking at the measures of central tendency in a group data now. But what is a group data? So a group data, it's the data that has been organized into groups or categories, no? Known as the classes or the intervals. Instead of listing each individual data point, data is grouped into ranges and the frequency of data points within each range is recorded. Grouping data is useful when dealing with large data set as it simplifies the data, making it easier to analyze and also to interpret. Okay, so let's look at example number 6. 50 students wrote an entrance examination for entry into the Faculty of Science at a university. The results were reported as a grouped data. So in interval 0 is to 20, you have how many data set there? You've got 4. Between 20 and 40, you have how many? 11. Between 40 and 60, you have 20. And between 60 and 80, you have 10. And between 80 and 100, you've got how many data set? You've got 5. So now you need to know how to find the estimated mean. Remember, now we can't find the actual mean because you are not given the exact data set, but now you are given your data set in a grouped form. So you are given that in the first class or the class interval of 0 is to 20, you have how many data set? It's 4. You are not given the exact number. Ne? So the only thing that you can do there, you can find the estimated mean, but not the exact mean. Letter B, you need to find the median. So you need to know where your median lies. It lies in which class interval. And then you move to C, you need to find the mode. How do you find the mode? Okay. So let's start with the estimated mean. So first things first, before you can find the estimated mean, you need to find your midpoint. You can just extend your table on the side, ne? You can just extend it the side, and then you find your midpoint. You find. Okay, let's start with the midpoint. So the midpoint, how are you going to find it? You are going to say the midpoint of this class interval, which is 0 and 20. You'll say it's 0 plus 20. You divide it by 2. Then it is going to give you 20 divided by 2, which is 10. Then you move to 20 and 40. You will get 20 plus the 40, which is going to give you a 60. Then you divide it by 2, then you'll get a 30. And then you move to 40 and 60, you'll get 40 plus the 60. You divide it by 2. It's going to give you 100, and then it's going to give you a 50. So let me just write it on the side. It's 10, it's 30, it's 50. Then you have 60. You have 60 plus the 80. You divide it by 2. I think that's going to give you 140. Ne? And 140 divided by 2, it is going to give you a 70. So it means here you'll get a 70. And then you say 80 plus 100. You divide it by 2, that's going to be 180. And if you divide 180 by 2, you will get a 90. Ne? So that's going to be a 90 on the other side. So now you've got your midpoint. We represent our midpoint as X. Ne? So you are done with that column, and then you just extend another column on the side where you can find the midpoint times the frequency. So now we are going to multiply this frequency with this midpoint. So the first value value you'll say it's 4 times 10. So if I multiply the 4 and the 10, I am going to get a 40, right? You'll get a 40 here. And then again, you multiply the 11 and the 30. So if I say 11 times the 30, I am going to get 330. So you get 330. And then again, you are going to multiply the 20 and the 50, right? So you'll get, if you say 20 times 50, you'll get 1,000. Okay, and then you multiply the 10 and the 70. So if you say 10 times 70, you'll get 700. And then lastly, you'll say 5 times that 90. So it is going to be 5 times the 90. You will get 5 times 90, you will get 450. Then after doing all of this, you are going to find the total of the frequency. The total of the frequency, if I add everything here, it should give me 50. Ne? Let's just confirm. You'll say it's 4 plus 11 plus 20 plus 10 plus 5. Then you are getting the 50, right? And then you need to find the total of x times the f, the midpoint times the frequency now. Ne? So we need to add everything going down. So I'll say it's the 40 plus the 330 plus the 1000 plus the 700 plus the 450. Then I'll get 2,520. So for me to find my estimated mean, I'll say my estimated mean it is equals to 2,520, and then you divide the whole thing by the sum that you got when you were adding your frequency. Ne? So it means in that case you'll divide by 50. So if I say 2,520 divided by 50, I will get 50,4. Ne? That is going to be 50,4. So it means your estimated mean is 50,4. Don't forget, estimated mean, it's so easy to find it. It's just that it needs you to focus. So you find the midpoint interval by saying the 0 plus the 20 you divide by 2, the 20 plus 40 you divide 20 plus 40 you divide by 2, 40 plus 60 and you divide by 2, 20 plus 80 you divide by 2, then 80 plus the 100, then you divide by 2, right? And then those values that you got, you need to multiply them with the frequency. So you'll say the answer that you got here, when you were finding the midpoint, you multiply it with the frequency. The value that you got here, you multiply with the frequency. The value that you got here, you multiply with the frequency. Again, you multiply with the frequency and multiply with the frequency. Then after multiplying with the frequency, you need to add everything. You need to add everything that you got when you were multiplying the midpoint and the frequency. Then you divide that by the total of the frequency, then you'll get your estimated mean. It's easy, ne? I know. Okay, and then let's move to finding the median. So the median, it's still the 50% of the data set or the half of the data set. So the only thing that you need to know here, you can't find the exact value of the median because now we are working with the group data. But you can find where the median lie. Ne? So you say the position, it is equals to 1 all over 2 into n plus 1. So the n in this case, This n, you now put what? You put the total of the frequency, right? So you have added everything in your frequency table. You add everything, you add everything, then you'll get the 50. So it means the n, it's gonna be that 50. So let me do it. So I'll have 1 all over 2 into 50 plus 1, which is 51 divided by 2, and it is going to give you, I think, 25,5. Okay, so you need to go back to your frequency and check where 25,5 is going to be, ne? Okay, so first things first, I come here, I've got a 4, right? And then if I add the 4 with this 11, it's like you're finding the cumulative frequency. I don't know if you still remember the cumulative frequency. So you'll have the 4. Then if you add the 4 with the 11, you'll get a 15. And if you add the 15 with the 20, you will get 35. And if you add the 35 with the 10, you will get 45. And if you add 45 with the 5, you'll get a 50. To know that your cumulative frequency is correct, the last value of the cumulative frequency should be the same as the sum of the frequency, né? Okay, sharp. So we are looking for 25,5. So you come to your data set, you've got 4. If you say 4 plus 11, we are getting 15, right? So it means your median, it can be in this class interval. Why? Because in this class interval, you've got how many data set? 15. Okay, then you add the 20. If I add the 20, I can see that my median is going to lie where? It's going to lie at 40 and 60, because if I add, I'll end up having the 35. So my 25,5 is going to be somewhere inside that 35. Ne? You can't continue to 45 because now it's above that 25,5, right? So it means your median will lie where? Will lie at 40 and at 60. So it means my median, it lies in that class interval whereby x is greater than or equals to 40 and also less than 60. So you'll get how many marks? You get your 2 marks there. Okay, and then the mode is very simple. Remember, when we are dealing with the ungrouped data, we said the mode, it is going to be the most frequent value, right? So now your mode in a grouped data is going to be the one with the highest frequency. So if I'm checking my frequency, I check the class interval with the highest frequency. So if I check nicely, I can see here I've got 4 data set, I've got 11 data set, and then I've got 20, I've got 10, I've got 5. So it means 20 is the highest. So it means my mode is going to lie where x is greater than or equals to 40 and also where x is less than 16. So it's going to lie in this interval as well because my frequency there, it's high. Ne? And then you get your marks. Okay, now let's look at the measures of dispersion. So we're looking at the measures of central tendency, which we use them to compare our data sets. Ne? So now we are going to look at the measure of dispersion, whereby the measure of dispersion, this is where now we are looking at how our data set it is spread around the mean or around the median. Ne? So the measure of dispersion, it helps us to determine how data is spread around the median or the mean. So in our measures of dispersion, we've got our range, we've got our quartiles, we've got our percentiles, our interquartile range, and our semi-interquartile range. This is just revision. I know you do remember this from grade 10, right? Okay. Let's start by looking at the range. So the range is the difference between the largest and the smallest value in the data. The bigger the range, the more spread out is the data. Ne? So let's look at example 7. So in example 7, I can see that my smallest value here, I have 1. Yeah, my smallest value here is given as 1. So smallest value, it is given as 1. And then your largest value, it is given as 10. Okay, so for you to find the range, you need to say the largest minus the smallest. So the largest value is 10 minus 1, and you'll get a 9. A range, it is very easy to find it. You just say the maximum value minus the smallest value, or you say the maximum minus the minimum value, of which is going to be the 10 minus the 1, and then you will get your 9. So your range is given as the 9. Ne? Okay, let's move to the quartiles. So your quartiles subdivide a data set into quarters, of which it's 4 groups. So you've got your lower quartile, you've got your median, and then you've got your upper quartile. So when we are looking at our lower quartile, we are looking at the 25% of the data, which is 1 all over 4. And then when you are finding the position, you say it's 1 over 4 times the n plus the 1. Then the median is the one that we've been talking about. You know that we are talking about 50% of the data. So if you say this 25% plus this 25%, you'll get the 50. So your Q2, it contains 50% of the data. Ne? And then when you are looking at the upper quartile, whereby now we are saying the 25 plus the 25 plus the 25, you will get your Q3, which is 75% of the data. Ne? So how do you find the Q1, Q2, and the Q3? Okay, firstly, the quartiles, they provide an indication of the dispersion around the median, and especially useful in a set which contains outliers. So outliers in grade 10, we do touch just a little bit on outliers, but you will focus a lot on outliers in grade 11. So outliers, it's that value that is the smallest, and maybe you find that it's the biggest. It's not within the data. Maybe the data, it's starting from 3, maybe it's 4, it's 5. I'm just making an example. And then you find that your data, maybe it's ending at 10. And then you have this one value, which maybe is at 20. So that value that is much far from your data set, we call it the outlier. Ne? Okay, so the data has to be ordered to determine the quartiles. So for you to determine the quartiles, you need to make sure that your data set is in order, or it's in an ascending order, or it's in an increasing order. So make sure that always you write your data set from the smallest to the biggest. Ne? Okay, so we have 3 quartiles. I have already mentioned that. So we've got the Q1, which we call the lower quartile. We've got the Q2, which we call the median. And then we've got the Q3, which we call the upper quartile. And then, so the median of the lower half of the values in the data set is the lower quartile, which is 25% of the data. So for you to find the lower quartile, you have to say, to find the position of the lower quartile, you have to say it's P, it is equals to 1 all over 4 into n plus the 1. Remember, lower quartile is 25% of the data. If you convert the 25 into a number, you get 1 all over 4. Ne? And then the median, I had already explained this one. We said to find the position of the median, you have to say 1 all over 2 into n plus 1, right? And then the last one, which is Q3, to find the median of the upper half of the data set, you are going to say it's P, it is equals to 3 into n plus 1 all over 4. Why are we saying 3 over 4? Because it is the 75% of the data set. And 75% of the data set, if you convert it to a number, you'll get the 3 all over 4. Ne? Okay, so steps to calculating quartiles. Number 1, you have to write the data in order and determine the median. And then number 2, you need to determine the lower quartile, Q1, by finding the median of the lower half. Okay, and then 3, you need to determine the upper quartile, Q3, by finding the median of the upper half. Okay, so let's look at example number 8. It says the table below shows the percentage that 7 students obtained in a mathematics test. Determine the median as well as the upper and lower quartiles for the set. Okay, so let's check nicely. Is it arranged in an ascending order? No, because I can see I have 75 and then I have a 50, right? Okay, so let's arrange our data in an ascending order. So if I arrange my data in an ascending order, I'll have 50. I'm done with 50. Do I have any 50 something? Yes, I have 52. I'm done with 52. Do I have any 50s? No, I'm done with 50s. And then I move to 60s. I have 60. Okay. And then do I have any 60 somethings? No. Do I have a 70? Yes, I have a 75. Do I have a 70? Again, I have a 78. Yes. And do I still have another 70? No. Do I have a 80? Yes, I've got an 82. And then lastly, I have 95. Ne? So now my data set has been arranged in an ascending order. Okay, so now I can use my data set to find the lower quartile, the median, and the upper quartile. So let's start by finding the median. Remember, I said to find the median, you'll say the position, it is equals to 1 all over 2 into n plus 1. So it's 1 over 2 into your data set. You have got how many values? It's 1, 2, 3, 4, 5, 6, 7. Ne? It's 7 plus 1. So it means you will have 7 plus 1, which is 8. You divide it by 2, then you'll get a 4. So it means your median will be in position 4. Okay? So I've got position 1, position 2, position 3, and position 4. So it means my median is at position 4, and it is given as 75. So I've got Q2, it is equals to 75. Then I'm done with finding the median. So now I need to find the lower quartile. Remember, the lower quartile, we are now looking at the middle value of the lower half of your data set. So my lower half of the data set, it is now 50, 52, and the 60. So this is my lower half. So in my lower half, I can see that 52, it is going to be the median of this lower half, this one. What is the median of that lower half? It is going to be 52, just by looking at the data set. So you can see that your Q1 will be given as 52. But what if you had a lot of data set? What do you do? So you can just find the position. I said, how do you find the position? You will say your position, it is equals to 1 all over 4. Where am I taking the 1 over 4? Because we are talking about the quarter of your data set, or 25% of the data set, right? So it's 1 over 4 into n plus 1. So I will have 1 over 4. My n, it is given as 7 plus 1, because I've got how many numbers in the data set? It's just 7. So I'll get 7 all over 7 plus 1, which is 8, and then 8 divided by 4, I'll get a 2. So it means my lower quartile, it is in position number 2. So I come here, I say position 1 and position 2. So in position 2, I am getting the 52, of which it's my lower quartile, or my Q1, right? Okay, and then I move to Q3, which is my upper quartile. So upper quartile, we are now looking at the middle of the upper half of the data set. So from here, I can see this is my upper half of the data set, right? Make sure that you exclude your median. Okay, so here I can see the median of this upper set, it is going to be 82. So it means my Q3 is 82. But what if you had a lot of data set? You can just find the position. So the position, I said it's 75% of the data. Ne? So it is going to be P, it is equals to 3 all over 4. Then you multiply that by N plus 1. So it is going to be 3 all over 4. Your N, you've got 7 data set plus 1. And then it is going to give you, just put everything in a calculator, you'll get 8 times 3, which is going to give you 24. Then you divide it by 4. So 24 divided by 4, it gives you 6. So it means your Q3, it is going to be in position 6. So let's go to our data set in position 1, position 2, position 3, position 4, position 5, and position 6. So in position 6, I'm getting 82. So it means my Q3, it is given as 82. Please do not make a mistake of finding the position and just leaving it there. So after using this equation, you must know that you haven't gotten your lower quartile, your upper quartile, or your median. The only thing that you got, it was the position. Are we together, guys? So after finding the position, you still need to go back to your data set and you find your Q2, your Q1, and your Q3. Ne? Okay, let's look at example 9, whereby now you've got your median as 2 values, or your median as an even number. Okay, so the table below shows the percentages that 12 learners obtained in a history test. Determine the median, which is your Q2, as well as the upper, which is your Q3, and the lower, which is your Q1, quartiles for the data set. So before we can find our quartiles, we need to arrange our data in an ascending order, right? So don't forget, arrange your data set in an ascending order. Okay? So let me start. Which one is the smallest one here? I've got 50, I've got 60, I've got 50 is the smallest one. Do I have a 51? No. Do I have a 52? Yes. And then it's 52. Do I have a 53? No. 54? Yes. Do I have a 55? No. 56? No. 57? No. 58? Yes. Do I have a 59? No. A 60? I don't have a 60, but I do have a 62. Oh no, I do have a 60. And then I have a 62. So here's the 60, and then I have a 62. Do I have a 70? Yes. Oh no, I have a 64. Do I have a 65? No, we don't have a 65, right? And then do I have a 60 something here? No, it's finished. And then we move to a 70 and then a 71. So I have a 70, I have a 71. And then I have a 73. And then I have a 75. And then I have a 78, right? So now my data is, let me just fix this one. This one is 60. So now my data set is arranged in an ascending order, right? So now I can find my Q1, my Q2, and my Q3. Okay, so first things first, I said you can just find your position, right? So my Q2, it is given as 1 over 2 into n plus 1. So it's 1 over 2 into how many data do I have, or how many values do I have in my data set? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it means I'll have 12 plus 1, which is going to give me 13 all over 2. Ne? And what is 13 divided by 2? It is going to give you 6,5. Ne? Okay, it is 6,5. Remember, the 6,5, it's not your median. Don't make a mistake of saying 6,5 is your median. 6,5 is the position of the median. So I go to my data set that I have arranged in an ascending order, and I look for position 6,5. Okay, so I've got position 1, position 2, position 3, 4, 5, 6. So position 6,5 is going to be in between here, right? Okay, so it means even if I start this at, let me see, 1, 2, 3, 4, 5, 6. 6,5 is going to be between 62 and 64. So it means my median will be given as 62 plus 64. Then I divide by 2. So it's going to be that 62 plus 64. It is going to give you 126. And if you divide by 2, you get 63. Ne? So it means your median, it is 63. Are we together? Okay. So now I can find my lower quartile, which is 1 over 4 into n plus 1. So I'm still finding the position. So my position of the lower quartile, this is the position. Don't be mistaken. So this is the position as well. Position, it's 1 over 4 into how many data values do I have? 12 plus 1. Then that one is going to be 13 divided by 4 now. Then I get 3,25. Okay, so my position of the lower quartile is going to be 3,25. So it means if in my data set I can go to position 3,25, I'll get my lower quartile, right? Okay, so I've got position 1, position 2, position 3. So it is going to be 3,25. So it's going to be somewhere here. Let me see. Yes, it's going to be somewhere here. So if you check at your lower half of the data set, so now in your lower half of the data set, you include everything, including that 62. Because remember, that 62 is not a median. It's not your Q2. But we said the Q2 is between the 62 and the 64. So when you are finding your lower quartile, you need to include that 62. So if I count at my data set, I can see I've got 1, 2, and then I've got 1 and 2. So it means my lower quartile will be between 54 and 58, right? Okay, so I say my lower quartile, Q1, it is equals to 54 plus 58, then I divide by 2, ne? So 54 plus 58, it gives you 112. Then if you divide it by 2, you get 56. So it means your Q1, it is given as 56. Okay, and then from there I can move to Q3. Let's move to Q3. So Q3, again, we're going to find the position first. Position of the Q3. So how do you find the position of the Q3? You say 3 all over 4 into n plus 1. So it is going to be 3 into 12 plus 1. Then you divide by 4. So 12 plus 1, you get 13, and then if you multiply that by 3, you will get 39. So 39, you divide it by 4. And if I divide my 39 by 4, I'll get 9,75. So it means if I go to position 9,75 in my data set, I'll get my Q3. Okay, so I go to my data set, position 9,75. It's 1, 2, 3, 4, 5, 6, 7. 7,5 is going to be somewhere here in between. Let's check this side. 1, 2, 3, 4. This is my lower half of the data, so it's going to be 1, 1, 2, 2, 3. Okay, let me just erase a little bit because it is too busy here, né? Okay, so we had said we have 50, we have 52, we have 54, we have 58, and then we said we have 60, and then we said we have 62, and then we said we have 64, and then we had said we have 70, 71, sorry, and we have it's 70, 71, we have 73, we have 75, and then we have 78, right? Okay, so we had said our median, or our Q2, is going to be between the 62 and the 64, right? Meaning that our upper half of the data is going to be here. This is our upper half of the data. So if I'm looking at if I'm looking for my upper quartile here, I'll say it's 1, 1, 2, 2, and then I'll get my weekly term at 71 and also the 73. So how do you write that? You'll say your Q3, it is equals to 70 plus 73. You divide by 2, and if you say 70 plus the 73, you will get 143. And if you divide that by 2, you get 2, right? And then you get your full marks. You don't have to do this though. You can just use your formula of finding the position. You go to your data set, you count your data set. When you go to position 9,7, then that's where you are going to get your Q3. Okay, I hope you understand, because we'll be using these quartiles to sketch our box and our whisker plot. Okay, so let's quickly move to the interquartile range. So interquartile range is the difference between the lower and the upper quartile. It is a good indication of how the data is spread about the mean and is not affected by outliers. And it is based on the meagly half of the data. Unlike the range, whereby the outliers, they do affect, whereby our range is affected by our outliers. If you have outliers, your range is going to be misleading. Okay, so but with an interquartile range, it is not affected by outliers. For this reason, it is more accurate a measure of dispersion than the range. Okay, so how do you find your interquartile range? So interquartile range, you say your upper quartile, which is Q3, minus your lower quartile, which is Q1. So it means, first things first, you need to arrange your data in an ascending order, find the upper quartile and find the lower quartile. After finding those two, then you can now find the interquartile range by subtracting the lower quartile from the upper quartile. So for instance, let's look at this example whereby your median is 82 and your Q3 it is given as 92, and then your lower quartile it is given as 77. So for you to find the IQR, you'll say the interquartile range, it is given as Q3 minus Q1. So your Q3 it is going to be 92 minus your Q1 it is going to be 77. So if you say 92 minus 77, you get 15. And then let's move to that example. So the table below shows the percentage that 7 learners obtained in a test. Determine the interquartile range for this data. Okay, so the table below shows the percentage that 7 learners obtained in a test. Determine the interquartile range for your data. So before you can find your interquartile range, you need to know that your interquartile range, of which is your IQR, it is given as Q3 minus Q1, right? You say upper quartile minus the lower quartile. But for you to find the upper quartile and the lower quartile, you need to have a data set that is arranged in an ascending order. So let's go back to our data set and arrange it in an ascending order. I have 60. I have 63. I have 65. I have 68. Okay, and then I have 70. And then I have 72. And then I have 75. Right? Okay, so now I can find the position of the lower quartile. But I don't have to find the positions, because my data set, it is small. Okay, so let me just do this. Let's first find our Q2. So I have 1, 2, 3, 4, 5, 6, 7. Okay, so it means your median is going to lie here. So this is your Q2, right? So the median of the lower half of your data, it is going to be given as 63. So it means your Q1 is given as 63. And then this side, the median of the upper half, it is going to be given as 72, right? Because 72 is in the middle when you're looking at that data set. So your Q3, it is going to be given as 72. Then from there, we can find our IQR. So you say it's IQR, it is equals to Q3 is 72 minus our Q1, it is 63. So we have 72 minus our 63, and it gives us a 9. You see how easy it is? So your IQR, it is given as 9. Okay, and then the semi-interquartile range. So now you've got the semi. So it means in your interquartile range, now you need to divide it by 2. So your semi-interquartile range is the half of the interquartile range, meaning that it's going to be given by Q3 minus Q1 all over 2, of which is just your IQR all over 2. Remember your IQR, we said you find it by saying Q3 minus the Q1. So your semi-interquartile range, you'll find it by saying your interquartile range divided by the 2. Let's look at example number 9. It says, given that the IQR in the previous example is 9, okay, determine the semi-interquartile range. So semi-interquartile range, we said it is going to be given by Q3 minus Q1 all over 2. But already we had gotten Q3 minus Q1, right? We said it was given as 9. So it means you'll just say 9, then you divide the 9 by 2, and you'll get the 4,5. So it means your semi-interquartile range, it is given as the 4,5. Okay, let's quickly look at percentiles. So percentiles divide a data set into intervals, such as tens or hundreds. It tells you of what data lies below and above a specific data point in a data. In other point, if a data point is in 80th percentile, it means that 80% of the data is equals to or below that value, and that 20% of that data lies above it. So how do you find the position of a percentile? To find the position of a percentile, you'll say percentile, okay, all over 100 times the number of values in a data set. So if they say maybe find the 80th percentile, you'll say it's 80 all over the 100 times the number of values in your data set. Then you'll get the position of the percentile. This equation, it doesn't give you the percentile, ne? It gives you the position of the percentile. Okay, so steps to calculating percentiles. You need to write your data set in order. You need to determine the position of the asked for using the above formula, and then you need to determine the actual value of the percentile by counting up the ordered data set. Okay, so let's look at example number 10. It says determine the 30th and 65th of percentiles of the data set below. So you are given your data set. Obviously, before you can do anything, you need to do what? You need to arrange your data set in an ascending order. So I can see the smallest value there is 5. So I have 5. And then do I have a 6? No, I don't have a 6. And then I have a 12. And then I have a 18. Do I have a 20? Yes, I have a 20. And then I have a 22. And then I have a 24. And then I have a 25. And then I have a 26. And then I have a 29. And then I have a 32. Ne? So I have all my values. I have arranged everything in an ascending order. Okay, so from there we need to find the position of our 30th and 65th of our percentile. Okay, so you'll say the position, it is equals to your percentile divided by 100, and then you multiply by the number of the data set. Ne? So the percentile, it is given, let's start with the 30th. So you'll get 30 divided by 100, and then times the number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. Ne? So if I multiply there, I think I'll get a 30. Okay, so it means in position 3, I will get my 30th percentile. Ne? So I go to my data set 1, 2, 3. So it means my data set, 30% of the data set, it lies below or at 18. Ne? So it means at 30th, my 30th percentile, which is in position 3, I'll get that 18. Ne? Okay, and then or 3 values of my percentiles, they lie below the 30th percentile. Okay, so I've got P again. For that 65th one, it's going to be 65 divided by 100, and then I multiply by the 10. Ne? So I get 65 divided by 100. I get 0.65, and then I multiply that by 10, and then I get 6.5. Okay, let me change my color. I go to my data set. I've got 1, 2, 3, 4, 5, 6. 6.5 is going to be somewhere here. It's in between 25 and it's in between 24 and 25. So it means my 65th percentile, it lies below or at 25 plus the 24 plus the 25 divided by 2. Ne? So I've got 2 values because it's in between the 2. I'm not sure what is that value. So I have to say 24 plus 25, I divide by 2. So I'll get 24 plus the 25. Then if you divide it by 2, you are going to get the 25. So the position of the 30th percentile, it's in position 3. And then the position of the 65th percentile, it's in position 6.5. So it means 65% of my data set lies just before 24, ne? Just before 24.5, because it's in between 24 and 25. So it's just before the 25 because I got 25, ne? Okay. Let's move. I hope you understand. If you have any questions, please don't be afraid to post your questions, ne? Okay, so example number 11. Now let's work with the grouped data. So now we need to work with the grouped data to find our quartiles, our range, your semi-interquartile range, and your interquartile range. So it says the following table shows the percentage that 199 grade 10 learners obtained in an exam, right? Okay, so between 0 and 20, I have 4 learners. Between 20 and 40, I have 47 learners. Between 40 and 60, I have 79 learners. And between 60 and 80, I have 50 learners. And then between 80 and 100, I've got 19 learners. Let's look at the questions. So the first question, it says, determine the interval in which the median lies. We have done this one already. Or let me just quickly do these ones, and then you will do the rest, ne? You'll do the rest at the end. Okay, so the median here, we say the position of the median, it is given as 1 over 2 into n plus 1. So you'll get 1 over 2 into, remember you need to find the total of the frequency, ne? So if I add everything here, I will get 4 plus the 47 plus the 79 plus 50 plus 19, I'll get 199. So 200 divided by 2, it is going to give you 100. So it means in position 100, I will have my median. So 4, let's find our cumulative frequency this side. So I write my 4, and then 4 plus the 47, you'll say 47 plus the 4, you'll get 51. And then 51 plus the 79, you'll get the 130. And then 180 plus 50, you will get 180. Then 180 plus 19, you will get 199. Don't forget, the total of the frequency should be the same as the last value of the cumulative frequency. So let's look for position 100. So if I say this plus this, I get 51. And then this plus this, I get 180. So it means my median is going to lie in this interval, right? So it means your median lies in which interval? It lies in when x is greater than 40 and when x is less than or equals to 16. Okay. And then let's look at the next one. Determine the interval in which the lower quartile lies. So first things first, you need to find your position of your lower quartile. So I set the position of Q1. You find it by saying 1 over 4 into n plus 1. Then you'll have 1 all over 4 into 199. Don't forget, we said the total of the frequency is 199 plus 1. So you'll say 200 divided by 4, and you'll get 15. So again, if you had added here, you'll get a 4, and then this one plus this one, you get a 51. This one plus this one, you get a 130. So it means your lower quartile is going to be at 51. It's going to be in which interval? In this interval, right? So it's when x is greater than 20 and when x is less than or equals to 14. And then you get your full marks. Let's look at letter C. It says determine the interval in which the upper quartile lies. So upper quartile, remember I said to you to find the upper quartile, you say the position, it is going to be 3 all over 4. And then inside the bracket, you'll have 199 plus 1. So it is going to be 3 times 200 divided by 4. So 3 times 200, it is going to give you 600. Ne? And then after this, you need to divide it by 4. If you divide it by 4, you'll get 150. So it means in position 150, you should have your upper quartile. So again, if you find your cumulative frequency, we said here it's 4, we said here it's 51, we said here it's 130, then we said here it's 180, and then 180 plus 19, we said it's 199. So we are looking for 115. Eh? So if you say 4 plus 47, you get 51. 51 plus 79, you get 130. Then 130 plus the 50, you get 180. So it means 150 is going to be somewhere in this interval. Ne? So you say in that interval you have x is greater than 60 and x is less than or equals to 80. Then you get your full marks. So with the group data, it's compulsory that you find the position first, because you can't just look at the data and say, I think the lower quartile will be here and I think the upper quartile will be here, because it depends on the frequency that you are given. So you need to find the cumulative frequency, and then after doing that, you need to find your positions. Ne? Okay. Let's look at letter D. It says determine the interval in which the 40th percentile lies. Remember, to find the position of the percentile, you need to say the position, it is equals to the percentile. In this case, it's 40, and then it's all over 100. You say multiplied by the total number, which in that case is 199. Okay, so you'll say it's 40 divided by 100, you get 0.4. Then you multiply by 199 and you'll get 79.6, which is, if you round it off, it's going to give you 18. So it means in position 80, you'll get your 48th percentile. So cumulative frequency, again, I've got my 4. If I add this and that, I get 51. If I add this and that, I get 130. If I add this and this, I get 180. And if I add that and add, I get 199. So it means 80% of the data, it lies in the 40th percentile. So if I check, I've got 4, I've got 51, and then I've got 130. So it means 80% of my data is gonna be where? It's gonna lie in the 40th percentile. So where is that? It lies where x is greater than 40 and where x is less than or equals to 60. And then you get your full marks. Quickly move to the estimated mean. We had already done this one. So I had said to you, you need to find the midpoint first, right? So your midpoint, we said we denote it as x. Ne? So you'll say 0 plus 20, and you divide it by 2, you will get 10. And then you say 20 plus 40, you'll get your 60. And if you divide your 60 by 2, you'll get 30. And you say 40 plus the 50, you get the 100. And if you divide it by 2, you'll get the 50, right? And then you say 60 plus the 80, which is going to be it is going to be 140. If you divide it by 2, you get 70. And then 80 plus the 100. And if you divide it by 2, you will get 90. Then from there, you need to multiply the frequency and the midpoint. So you'll say 4 times the 10, you will get. So here we are multiplying the midpoint times the frequency. So if you say 4 times 10, you'll get 40. And then if you say 47 times 30, you'll get 1,410. And if you say 79 times 50, you will get 3,950. And if you say 50 times the 70, now I'm multiplying this one, I am going to get 3,500. And if I say 19 times 90, I get 1,710, right? And then you find the total of everything. So 1,710, okay, let's start on top. So if you add 40 plus 1,410 plus 3,950 plus 3,500 plus 1,710, you will get your estimated mean. You will get 10610. It's all over. Then you need to divide by the total of the frequency. So you need to add everything here. Ne? So you'll say it's 4 plus 47 plus 79 plus 50 plus 19. Ne? And then you divide it by 199. So I will have 10,610 divided by 199, and then your estimated mean is going to be 53,32. This one, guys, is so easy, ne? Let it not confuse you. Okay, let's quickly look at the 5-number summary because we are out of time. Okay, so in the 5-number summary, you've got your minimum value. So the minimum value, even the word it says itself, it's the lowest value in the data set. So that lowest value in the data set, we call it the minimum value. And then you've got the lower quartile. You already know what is a lower quartile and how you find it, right? I said the lower quartile is the median of the lower half of the ordered data set, right? And then you have your median or your Q2. We said your Q2 or your median is the mealy value in an ordered set of data. If there is an even number of terms, the median will be the sum of the two terms in the mealy divided by 2, right? We have already explained this one as well. And then we have the upper quartile, which is Q3. I have already explained that one. And then we have the maximum value. Already I have explained the maximum value as well. Or rather, the maximum value is just the highest value in the data set. So that highest value, we call it the maximum value. Ne? Okay, and then this is how your box and your whisker diagram should look like. So you must have the minimum value this side on your whiskers, and then you must have the maximum value at the end, and then you must have the median or your Q2 in the middle, right? And then you must have your Q1 here, and then you must have your Q3 this side. Remember, your Q1, it represents 25% of the data. Your Q2, it represents 50% of the data. And then your Q3, it represents 75% of your data set. And then how do you find your interquartile range? Interquartile range, you find it by saying your Q3 minus your Q1, then you find your interquartile range. And then semi-interquartile range, you take your interquartile range and you divide it by 2. But you won't be needed to find that one. Okay, so the steps to drawing box and the whisker diagram. Number 1, you need to write the data set in order to determine the median. Remember, you can't find your quartiles, of which it's your Q1, Q2, and your Q3, when your data set is not arranged in an ascending order or in an increasing order. So you need to arrange your data set in an ascending order. And then number 2, you need to determine the upper and the lower quartile. And then thirdly, you need to draw an accurately scaled number line with a box on top of it from the lower to upper quartile and mark the median in the box. So make sure that when you are drawing your box and your whisker diagram, you have a scale. Your numbers, your spaces in between, they should be the same. So you make sure that you use a ruler. Ne? Okay, and then fourthly, you need to draw your whiskers from the lowest value in the data set to the box and from the highest value in the data set to the box. And then if they ask you, you need to determine if the data is evenly distributed, skewed to the right, or skewed to the left. So if they do ask you, you need to determine if your data is equally distributed, or it's skewed to the right, or it's skewed to the left. But we'll be focusing a lot on this in your next lesson. Okay, so example 12, the following data represent the percentages obtained in a math test for 7 students. So draw a box and a whisker diagram for the given data. So in position 1 you have 10, in position 2 you have 25, in position 3 you have 30, and in position 4 you have 50, and then in position 5 you have 60, and then in position 6 you have 75, and then in position 7 you have your 90. So likely for you, this data set has already been arranged in an ascending order, so you don't have to arrange it because they've already arranged the data set for you. Okay, so my 5-number summary, I'll have my minimum value. We said the minimum value, it's the lowest value of the data. In that case, it is going to be 10. Okay, and then I have my maximum value. My maximum value, it is given as 90. It's the highest value in that data set. You can see that it's 90. And then you have Q1. Let's start by Q2. Your Q2, okay, let's see. I have 1, 1, I have 2, 2, I have 3, 3. So it means my Q2 is going to be in position 4. So your Q2, it is given as 50. Remember, you can still use the method of finding the position and then going to your data set to look for your quartiles or your Q2. Okay, so your Q1, we are talking about the middle of your lower half of the data. So if I'm looking at the lower half of my data, I can see that the middle there, it is going to be in position 2. So it means here I'll have my Q1. So my Q1, it is given as 25. And then your Q3, it is going to be in the upper half of your data set, which is going to be 75. So it is going to be given as 75. And then you can always use the formula to find the position. Okay, so now I can sketch my box and my whisker diagram. Use a ruler to draw your number line. Make sure that you use a ruler. And then you must also make sure that you use a scale. So since I can see my numbers is 10, 25, 30, 50, 60, I'll use the scale of 10. Let me use the scale of 10. Let's fix this line. Okay, so I'm going to use my scale of 10. Make sure that your spaces in between, they are the same. So I'll start with 10, 20, 30, 40, 50, 60, 70. Now they're too clustered. Let's erase. Okay, use your ruler and then let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. The spaces in between in my number line, they are not the same, But since you are using a ruler, you'll make sure that the spaces, they are the same. So if in between you are leaving 5 spaces, you must make sure that you are leaving 5 spaces. If here you are leaving 5 spaces, you must make sure that you are leaving 5 spaces as well. Ne? Make sure the spaces in between, they are the same. And also your scale is correct. So I have 10, I have 20, I have 30, I have 40, I have 50, I have 60, I have 70, I have 80, and I have 90. Making sure that your scale is correct, ne? It's going to help you when they ask you the questions whereby they're asking you where the data, where your Boscan and whisker is skewed. Is it skewed to the right or skewed to the left? Because automatically it's just going to come out if your scale is correct. Ne? Okay, so let me start by plotting my minimum value. So my minimum value is at 10. So it means here at 10, I'll just put a line like that. And then my maximum value is at 90. So at 90, I'll just put a value like that. And then at 50, I'll have my Q2. So at 50, here's 50. I'll have my Q2. And then at 25, I'll have my Q1. So where's 25? 25 should be between 20 and 30. So if you have used a correct scale, when you are counting in between, you'll find the middle of 20 and 30, right? Okay, so I'll just assume mine is going to be somewhere here. And then Q1, it is, oh sorry, I'm done with Q1. And then at Q3, it is going to be a 75. So 75 is going to be between 70 and my 80, right? So if you have done a correct scale, make sure that the spaces they are correct and they are the same. So you'll see that it's going to be between the 70 and the 80 because it's 75. And then from there, you just construct your boxes. You just construct your boxes like that. Can you see? And then from there, you put your whisker and you also put your whisker. So you've got your Q2, you've got your Q1, then you have your Q3. This side, you've got your minimum value and you have your maximum value. Ne? And then you are done with your box and your whisker plot. It is very easy, more especially because now you understand your quartiles and you understand your 5-number summary. Ne? Okay, so in summary, you should be knowing your measures of central tendency of an ungrouped data. You must be knowing how to calculate the mean, median, and the mode by now. Ne? Okay, measure of central tendency in a grouped data. You should be knowing how to find your estimated mean, your modal class, and the interval where the median lies. Also, in your measure of dispersion, you should be knowing how to find your range, your quartiles, your box, and your whisker, and then your percentiles. I forgot to tell you, you can't find the range in a grouped data. Ne? You can only find your quartiles, your percentiles, your median, your mean, and the interquartile range. But the range, you can't find the range because you don't have the exact values. Ne? You can't say the largest value minus the minimum value because you don't know the actual values. You only have the interval. So in a group data, you can find the range unless in the statement they told you that the largest value is this and the minimum value is that. And okay, and then I also included a worksheet for you guys, November 2017 of the DBE. Please, when you find time, do that worksheet. You have question 1 whereby you are given an ungrouped data. 1.1, they're saying you must find the median, you must find the range, you must find the interquartile range, and then you must draw the box and the whisker diagram. Ne? And then the second one, now you have a grouped data, and in your grouped data, they're saying You must find how many days did the learner collect the data. Write down the modal class, of which is the mode, and then the estimate. You must estimate the mean, of which is the estimated mean. And then you need to calculate the percentage of days on which the temperature was at least 28 degrees Celsius. And then I'm sure you'll be able to do all of this because you were listening. I also have that other one of November 2018 that was extracted in the DBE. Thank you for tuning in, and don't forget, with mathematics you can't just learn just by watching these videos only, but you must make sure that you watch these videos and then you practice. Make sure that you practice until you get it right. You don't need to cram the answers, but you need to make sure that you know the method, because when we are marking the method and not the answers. Thank you for tuning in.